Hello everyone. In today's session, we will explore how to efficiently create a virtual private cloud in AWS using Terraform modules, streamlining the process of infrastructure provisioning and management. So these are the table of contents which we are going to learn today. We will start with what is Terraform. So it is an open source infrastructure as code software tool where you define and create resources using providers in a declarative configuration language. Example, JSON. With Terraform, you can package and reuse the code in the form of modules. It supports a number of cloud infrastructure providers such as AWS, Microsoft Azure, GCP, IBM Cloud, etc. Further, we will learn about VPC in Amazon Web Service. AWS VPC is a logically isolated section of the AWS cloud where you can deploy and run AWS resources. It allows you to create a private network in the cloud, providing control over the virtual networking environment, including IP address, ranges, subnets, and configuration of route tables and network gateway. What are the components of VPC in AWS? The first component is private subnet. So no direct internet access is suitable for resources needing enhanced security like database. Public subnet. It has a route to the internet via internet gateway used for resources that require public accessibility, such as web server. Internet gateway, a scalable and a redundant component that enables communication between instances in a VPC and the internet, allowing resources in a public subnet to connect to the internet and vice versa. Route table for public and private. So route traffic in and out of public subnet directing it through the internet gateway for internet access. And route table for private directs the traffic within the VPC, typically without a direct route to the internet. It is used for the communication between instances in different subnets. Security group. It acts as a virtual firewall for instances. It controls inbound and outbound traffic based on rules defined by the user, providing an additional layer of security. And NAT gateway, a managed network address translation NAT service that allows instances in a private subnet to initiate outbound traffic to the internet while preventing inbound traffic from reaching those instances. So it is useful for instances without public IP. So the VPC is a virtual network that will enable you to launch and operate resources in logically isolated section of the cloud. So if you think of a VPC as private secure network, it will provide in the cloud environment. So it is similar of an office building might have a private network for internal communication and resource sharing. So here is an interesting example. So for subnet, in office there are multiple floors. So subnets are like separate floors within the office building. So each floor subnet may serve as specific purpose or a group of employees and communication between floors is controlled and managed. And internet gateway can be considered as the main entrance of the office. So the internet gateway is like the main entrance of the office building. So it allows resources within the VPC to connect to the internet or it can be accessed from the internet. And the route table can be considered as the instruction or office map. So it will direct the traffic within the office building. So it will define how traffic should be flow between different subnets and the internet. The security group can be used as for access control system. So the security group will act as an access control system defining rules for inbound and outbound traffic, which is ingress and egress blocks. So they specify who or what can enter or exit specific areas such as subnet of the VPC. And then the elastic IP which will provide a fixed IP. For example, as it will provide a fixed office phone number. So an elastic office is like a fixed office phone number. So it will provide a static public IP address that resources within the VPC can use to communicate within the external world. Next, we will learn about what is Terraform module. A Terraform module is a set of configuration code files with structured folder architecture. We can create this module to combine resources that are used for specific single operation, which reduces the lines of code needed to create related infrastructure components. So what are the components of module? A typical Terraform module consists of following components, which is main.tf, variables.tf, output.tf, and readme.md. So the main.tf file contains the main configuration for the resources defined in the module, and the variables.tf file will define input variables that users can customize by using the module. And the output or TF file will specify the output values that users can retrieve when the module is applied. For example, as instance web IP address. And the readme.md will document the detailing of how to use the module, including variables, outputs, and any specific consideration. So the Terraform modules follow the dry principle. So the dry principle specifically applies for the software development area, which in the infrastructure as a code can also be used. So this dry principle defines don't repeat yourself, which is basically a principle for software development which is aimed at reducing the number of repetitive patterns within the software code. So what are the types of Terraform modules? So with Terraform, we will likely come to across one of the three main categories of the modules. First is root module. So the primary entry point of Terraform configuration contains it contains the main configuration file, typically orchestrating the deployment of multiple resources, and it serves as top level module in a Terraform project. Second is a child module, subordinate module encapsulated within the root module or other child module. It focuses on specific functionalities or resources contributing to the modular structure of the infrastructure code, and it enhances code organization and maintainability within the broader project. So the root module can be considered as our main project, and the child module where we can use that project as a reference when we create another project similar type. And the published modules are those which we can use from the GitHub. So this will reduce our time and we can create efficiently our project. So the published module will provide external module shared and published for broader use. And it can be created by the community or organization to facilitate the reuse of well-designed infrastructure components. So it can be accessed through various sources such as Terraform registry, offering build solution for common infrastructure patterns. So how Terraform module can apply across different environments. So development environment. So the purpose is to customize models for rapid development and testing. Example, in the development environment, we use smaller instances types and enable debugging feature for faster iteration. For example, as T2.micro. And in staging environment, the purpose is to test integration with realistic configuration. Example, in staging environment, adjust the configuration for larger instance type and use more realistic resource setting. And for production environment, the purpose is to emphasize high availability, scaling, and security. Example, in the production environment, configure models for larger instance types such as info.large, auto-scaling groups, and security measures. So in today's session, we will maintain a VPC project using Terraform modules. So as you can see, the VPC virtual private cloud, and in that VPC we have used three availability zones, which is AP South 1A, AP South 1B, and AP South 1C. And Each ability zone has subnet. So we will create 3 subnets of public and 3 subnet for private. And we will also create an internet gateway to provide access to the public subnet. And also we will create a NAT gateway to provide access for the private subnet. So our NAT gateway will, will be situated in the public subnet. So as the NAT gateway will itself require the internet to provide for the private subnet to access the private subnet. So that is why we use NAT gateway in the public subnet, and then it will provide the internet to the private subnet. So the AWS VPC is a networking service that allows you to create a private, isolated virtual network within the AWS cloud. So isolated virtual network. So VPC provides logically isolated virtual network environment where you can launch AWS resources such as EC2 instance, RDS database, and more. IP addresses. So we can define our own IP address range for our VPC, known as CIDR, classless inter-domain routing block. So this gives you complete control over IP address assignment and helps in network segmentation. So as we have learned subnets, routing. So VPC comes with a routing table that controls the traffic flow between subnet and to the internet. So you can define custom routing rules to direct traffic within the VPC or the external network. Internet connectivity. So by default, VPC provides internet connectivity to an internet gateway. So this will allow resources within the VPC to communicate with the internet, enabling access to external services and updates. Security. VPC offers built-in security features such as security groups and network access control list to control the inbound and outbound traffic at the instance and the subnet level. So these are the prerequisites we need to follow. So first you need to create an AWS account with the necessary permission to create and manage the resources. Second, you should install a Terraform extension in the Visual Studio Code editor, and the Visual Studio Code editor should be also installed. You can use another editor called as Atom also. Now we will start with the implementation. So this is the summary view of the Terraform files in our Visual Studio Code editor. So first we will create a provider.tf file. So before creating provider.tf file, we will go through the Terraform registry file. So just type Terraform registry on the search bar. And now you can browse modules. So in today's practical, we are using AWS module to create VPC. So click on AWS module VPC. So as you can see, this is the module where we can find in Terraform registry. And this is the code to create VPC. So by using this AWS VPC module in our existing Terraform modules, we don't have to write the whole configuration ourselves. So we are going to substitute our subnet model, and we will see what are the inputs, outputs in this project. So as you can see, the inputs are age is ability zone, which is the list of ability zone, the CIDR block, the database, internet gateway route, database subnet group. So these are the inputs, and we can also see the outputs, which will expose after applying the Terraform configuration. The list of ability zone, the list of ARNs of customer gateway, list of ID of customer gateway, database NAT gateway, and you can see the resources, the list of resources in this module which is available. So there are total 80 resources. So as you can see, they are using the version 5.4.0. Now we will go back and we will create a provider.tf file in Visual Studio Code. So the provider.tf file in Terraform is a configuration file that specifies the cloud provider and its corresponding plugin that Terraform will use to manage resources in that provider. So the provider.tf file is used for the following: provider declaration, authentication detail, region specification, and version constraint, and additional settings. So as you can see, this is a provider.tf file. Now open the Visual Studio Code editor and you can see the Terraform provider.tf file. So this will begin the configuration block for Terraform. So it will define the global setting for our Terraform configuration. So the required providers block is used to declare the required providers for the configuration. In this case, it specifies the configuration requires for the AWS provider, and the source specifies the source of the AWS provider. So in this case, as you can see, it is HashiCorp AWS and the version is used is 5.6. So this line will specify the version constraint for AWS provider, and it will indicate that any version equal to or greater than 5.6 is acceptable, and the required version is set to 0.13. So this line will specify the required version of Terraform. In this case, it is set to version 0.13 or any version above. And we have declared the provider AWS and the region we are currently using is AP South 1, which is Mumbai, and the profile which contains our access key and secret key. Now we will create vpc.tf file. So in Terraform, vpc.tf file typically contains the configuration code for creating and defining an Amazon Virtual Private Cloud, along with its associated resources. So now we will create an vpc.tf file. So in this, so the Terraform code will appear using a module. So this is the path which is used from the Terraform registry. So as you can see here the source code and the path, and in provision instruction also. So this is the path, and then we will create our Amazon Virtual Private Cloud VPC on AWS. So first we have declared a Terraform module named VPC, as you can see, and the version is 5.0.0. And next we will specify the details and the name of the VPC by combining the value of the var name and the local. So this will provide an unique identifier for the VPC and the CIDR block. So here you can see we have mentioned the variables. So here you can see the CIDR block, which is set to default range 10.0.0 slash 16 IP address, and the age, which is the availability zone, and in variables.tf file you can see the type list string, and it will set to default to availability zone AP South 1A and AP South 1B. Next is for public subnet and private subnet. So this line will set the public subnet for the VPC and the values are provided through the variables. So as you can see in the variables.tf file, the list of the IP address are given and the range is from 10.0.101.0 to the 102.0, and you can see above here variable private subnet type is list string and the default blocks are 10.0.1024 to the range of 10.0.2/24. Next is the database subnet. So this line will set the database subnet for the VPC and the values are provided through the variable.database subnet. So as here you can see variable.database subnet, this, the blocks are mentioned here, IP address starting from the range 10.0.151 till 10.0152.0/24. And next we will create an subnet group and subnet route table which is for database, and the variables you can see which is set to be type is equal to full and default is equal to true, and the VPC database route table is set to true. So it will create a database route table and control if its separate route table for database should be created. Next, the NAT gateways and outbound communication. So it will enable the NAT gateway. So here you can see for variable enable NAT gateway and it is set to true. So it will provision NAT gateways for each of our private network, and you can see the single NAT gateway which is set to true. So it will create a single shared NAT gateway across all our private networks. So the DNS parameters in VPC is set to true, which enable the assignment of DNS hostname and DNS resolution within the VPC. So the additional tags are given the reference for our local.tag. So here you can see the local.tf file and the tag name is local.owners and local.environment. And these are the additional tags for the public subnet, for which we have named as VPC public subnet. For private subnet, we have named it as VPC private subnet. For database subnet, we have named it as VPC private database subnet. And the instances launched into public subnet should be assigned to public IP address. So it will specify true to indicate the instances launched into the subnet should be assigned to public IP address. So it is set to true. Now we will create, as we have seen, the variables.tf file with the vpc.tf file. And now we will create an output.tf file. So an output.tf file in Terraform defines output values that you want to display after the infrastructure deployment, providing a way to expose specific information such as resources IDs or computer results for easier access or use in subsequent processes. So now we will check output.tf file. So as you can see, this is the outputs which we will get after we apply our configuration. So the first output will give a VPC ID, the second will give the CIDR blocks, the IP, and the third is private subnet, which will give a list of private subnet inside a VPC. And next, it will give the public subnet list inside the VPC created. And the VPC NAT gateway public IP will also be displayed in our output.tf file. And the list of ability zone will also be displayed after applying our Terraform configuration. Now we will learn about Terraform.tf vars file. So Terraform.tf var file is used to set values for Terraform variables, providing a convenient way to customize configuration without modifying the main Terraform files. So this file will allow users to input specific configuration details such as AWS region, environment names, or any other variable defined in Terraform code, making it easier to manage and share configuration. Now we will create Terraform.tf vars file. So as you can see, this is the generic variables values. The region is we are using is AP South 1. The environment we have set to prod, which is production, and the owners is AWS. And here you can see the VPC variables. So the name which we have previously seen as VPC Terraform for our VPC name, and these are the cider block. The ability zone which we have selected is AP South 1A, AP South 1B, and AP South 1C. And these are the IP address for our public subnet, which is 10.0.101 to the range of 1 10.0.103.0. And for private subnet, the range of IP address start from 10.0.1 to the 10.3.0/24. And the database subnet IP address blocks start from 10.0.151.0/24 to the 10.0.153.0/24. And to create the database subnet group is set to true. The subnet route table is set to true, and we will enable the NAT gateway and single NAT gateway, which is also set to true. So these values will be used by Terraform configuration to create or update the corresponding infrastructure on a cloud provider. So in this case, we are currently using AWS, and the configuration file provides specific setting for the VPC, subnets, and related sources. So after this, we can check the local.tf file. So it will declare the defining local values in the Terraform. So owner, as you can see in terraform.tf file, the owners is AWS, and environment is set to prod, and the name which creates a local variable name by concatenating the values of local owners and local environment variables with a hyphen in between. So this result in string is a combination of the owner and the environment values, and tags are set to be owner is equal to local dot owners, and environment is set to local dot environment. So this line will create a local variable name tag as a map. So the map contain key value pairs where the keys are owners and environment, and this value will correspond local variables local dot owners and local dot environment. Now we will deploy our configuration on AWS. So open an integrated terminal. So here, first type Terraform init command, which will initialize your Terraform working directory, and it will download the necessary provider plugin, and it will set up the backend as well. So it will download the modules which we are going to use from Terraform registry, which is a Terraform module for VPC. Type Terraform init command. So as you can see, it is initializing the backend, initializing the module, and initializing the provider required plugins. Now type Terraform plan to see what are the resources which we are going to add. So as you can see, these are the resources which are going to create after we type Terraform apply. So now we will apply our Terraform configuration. So type to apply, type Terraform apply and enter a value, type yes, which will apply our configuration. So as you can see, our Terraform apply configuration has been completed, and you can see 31 resources has been added, 0 change and 0 destroyed. And this is our output, which we have type in our output.tf file to get the required output after applying the configuration. So as you can see, the availability zone list, which is AP South 1A, AP South 1B, and AP South 1C. And our NAT public IP address is 13.200.230.25. And the private subnet and the public subnet and the VPC CIDR block range, which is 10.0.0/16 and a VPC ID. So now we will check this in our AWS console that if it has applied the configuration or not. So just visit AWS account and in search just type VPC. Click on VPC. So as you can see, this is the dashboard of VPC. Now we will click on VPC. So as you can see, there are two VPCs. So one is of default and one which we have created, which is VPC Terraform AWS Pro. So just click here and click on the second option, resource map. So this will give the overall view of our subnet created. So as you can see, the availability zone AP South 1A consists of one public subnet, two private subnet. So one is for private database subnet and same as in availability zone 1B and 1C. So as you can see, we have created 4 route tables, which is for VPC Terraform AWS production for DB, database, and for public, default, and private. So it is associated to the network connection and to internet gateway, and we have named it as VPC Terraform AWS Pro and the NAT gateway. So as you can see, for the private subnet which are connected to the route table, and it will give a route to the NAT gateway. So with this help, it will give internet access to the private subnets. And for public subnet, we have used internet gateway, which will be publicly accessed on the internet by the users. And third is the VPC private database subnet. So we have not provided any access as the database is situated in the private subnet. So it does not have any access because we need to secure our database. So we have not given the access to the database subnet. Now we will check the subnets. So here you can see there are two public subnets and two private subnets, three private subnets and three private database subnets. And you can check the respective route tables. So for public, you can see the routes which is internet gateway and the local. So if you click on the internet gateway, it will give the internet gateway ID. And here you can see that internet gateway has been created successfully. And here you can see the VPC ID and the tag name which we have given previously. You can see here owners, AWS, name, VPC Terraform, and environment production. And in route tables, you can see there are four route tables created. So one is of default route table, which we have not created. It is by default. And here you can see for the database, it is subnet associated with three subnets as we have created earlier. So here you can see the subnet, private database subnets, which are three. And here you can see the VPC. So this route table is created within our VPC. Next, we will check for our AWS public production. So here you can check the internet gateway. The route has been provided to the internet gateway. Subnet association, as you can see, three public subnet has been created successfully. And now we will check for our private. So as you can see, private subnet are accessed by to the internet by using NAT gateway. So the NAT gateway is in the public subnet as NAT gateway will itself require internet to provide the internet to the private subnet. So therefore, we have successfully created a VPC using an existing infrastructure on the Terraform registry. So you can also edit your configuration according to your requirement. So after your resource has been created, make sure you destroy or remove all the resources that were created on the Visual Studio Code. So we will conclude for today. So implementing AWS VPC creation with Terraform modules enhances scalability, consistency, and collaboration. So this modular approach simplifies customization, promotes code reuse, and ensures efficient management of AWS infrastructure. Terraform's abstraction of VPC configuration into module facilitates and standardized and organized deployment. For reference, you can visit the official website of Terraform registry as you need to create an existing infrastructure. You need to visit Terraform registry as I have told today. And if you have any queries, please contact us. Thank you for watching. And if you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more content. So feel free to leave your thoughts or suggestions in the comments below. See you in the next video. Thank you.